have 64 CPUs doing 128 things simultaneously is beyond your capability. You can't do it all at once. That machine would become overloaded. CPU utilization would go to 100%. Everything would start running much slower than it had in the past. If a fifth user came in and ran the query, we would try to do parallel 32 with it again, making the problem even worse. In 11G Release 2, once we've decided to do something in parallel, before we start running it, we look at what else is taking place in the system and ask the question, are there enough resources, given the amount of CPUs they have and the current utilization, to start running this query? If there are, we start running it right away. And it happens just like it did in 11G Release 1 and before. If there are not enough resources, we're going to put it in a queue. We're not going to start running it yet. We're going to wait a minute until those resources become available. In this fashion, everyone's query gets done faster than if we ran them all simultaneously. The people who are running right now finish fast because they're not contending for the CPU. The people in the queue, once they start running, will return their answers to the end user faster than if they had started right away. Simply because we don't have that resource contention. So this gives us the ability to utilize parallel query even when we have dozens or hundreds of users. Because we'll run them from this queue rather than running them all at the same time. The last change has to do with the way parallel query accesses data. When I started this section, I was talking about how things were in the year 1994. Very small memory, very disk-oriented. With parallel query, if we were to do a full table scan, parallel query would start by making sure that nothing for that table was in memory. It would flush the buffer cache, in effect, get it to disk, and just read the data from disk. Because parallel query was invented when memory was very small. When memory was very small, there was no way the entire table was going to fit in memory. It knew most of the table was going to be on disk. So rather than bother with the buffer cache, it would just empty it and do I/O against the disk directly. So anytime we ran parallel query, we would always read the entire table from disk, over and over and over again. Things are different in the year 2010. We have lots of memory on many of our machines. So they've now changed the algorithms for parallel query. When a query comes in, we're going to look at the table segment that we're going to be full scanning. And we're going to put it into one of three categories. We're either going to call that table small, medium, or large. If the table is small, we're not going to do anything special with it. We're just going to use the buffer cache like we would for any other release of Oracle. We'll read blocks from disk, put them in the buffer cache, get them out of the buffer cache. So parallel query will now use the buffer cache for the first time if the table is small. If the table is extremely large, it's bigger than we could fit into memory, we're going to process the table just as we have in the past. So if the table is very large, we will start by flushing the buffer cache of any blocks for that table and using direct reads against the disk to read it in. Here's the new bit. If the table could fit in memory, we will target it for this in-memory parallel execution. We'll look at all the memory allocated to the database If I'm running a single instance of Oracle, no clustering, that's just my one SGA. If I'm running in a clustered environment, it's the sum of all of the SGAs out there. So if I had two machines running my database, and each one had 256 gigabytes of RAM, I would have 512 gigabytes of SGA available for this in-memory parallel execution. The database would look at this table, divide it up across the nodes in a cluster. Half of you will go to node 1, half of you go to node 2, break the table into two, and ask each node to read that half of the table into memory. You'll read it into contiguous memory, and they'll compress it at the same time. So they're not reading it into the buffer cache, which tends to scatter blocks all over the place, but they're reading the table into contiguous memory and compressing it. That lets us full scan the table in memory rather than full scan it on disk. The first person who runs a query is going to have to do the physical I/O. But the second query, the third query, and so on, to just full scan that table out of memory, effectively removing the physical I/Os. So for many data warehouse tables that will fit in memory, you're going to see a massive change in the response times for queries that parallel process against them. So these three changes take into consideration the fact that we've got a lot more memory, our systems have gotten much more complex, assigning the degree of parallelism is hard, and we've got a lot of CPUs that we'd like to utilize. So queuing is something we need to implement. This makes parallel query easier to implement for everyone. Now the last one. This is number 10 and number 11. Cool new feature of 11G Release 2. It's a feature called addition-based redefinition. It's a feature of the database, meaning it comes with standard edition as well as enterprise edition. Everyone will have access to this new capability. So this is pretty exciting to me. What I think is the killer new feature of 11G Release 2 is a free feature of the database. Everyone will have access to it. What this capability is the ability for you to upgrade your application while the database is up and running and while users are using the old version of your application. Any DBA out there knows if they try to create or replace a stored procedure in a database that's running a production application already, that will never happen. They tried to do the create or replace, and if someone's running that stored procedure, because the old application is still running, the create or replace will become blocked. It will stop. Not only will it become blocked, but anybody else who tries to run that stored procedure will become blocked on that create or replace. And pretty soon the phone starts ringing. Hey, the database is hanging. What's wrong with it? And the DBA will Control-C, abort the command, and try again later. More typically, you're not just installing one stored procedure, you have 10 stored procedures to stick in there. The developers are making a fix to the code. They found a bug in procedure 1, and they had to change procedure 2, and procedure 3, and so on. You need to put in all 10 stored procedures with one command. You can't just put in one procedure and then have people run some of the new code and some of the old code. You need to fix everything at once or nothing at all. So application upgrades have always had you